Hello students, welcome back. I am Alejandro from Victory IB and CAIE Online Academy. During this video we will be discussing part B of problem number 3 of the 2019 AP Physics 1 exam. Now this problem as well as the entire exam is divided into subparts, so make sure you watch all the videos to have a complete understanding of all the concepts that are involved in the exam. Let's get started. Okay, part B of the problem. We are asked to design an experimental procedure to test a hypothesis in which the student uses the launcher to launch the sphere. Okay, so don't be creative in here. Assume equipment usually found in school physics laboratory is available. In the table below, list the quantities and associated symbols that would be measured in your experiment. Also list the equipment that would be used to measure each quantity. You do not need to fill in every row. If you need additional rows, you may add them to the space just below the table. Okay, so what are the quantities to be measured? Well, we need to measure all the quantities that will allow us to calculate the value for the spring constant. So we need to measure, the mass of the sphere. So number one, mass of sphere. Mass of the sphere. Symbol for quantity m or ms for mass of sphere. And how are we going to measure the mass? Well, we can use a triple beam balance. Which is a very precise instrument. Take measurements of mass. Triple beam balance. Okay, what else? We need to be able to measure the velocity that the sphere has once it is released. So quantity to be measured, velocity of the sphere. Velocity of the sphere, which will be represented by the symbol V or Vs. And the equipment that will be used is a motion sensor, something that measures how fast things are moving. Motion sensor. And lastly, the compression distance. Compression distance. It's represented by X, and a simple ruler will be fine. Now, this part is continued down here. We are asked to describe the overall procedure to be used to test the hypothesis that the spring constant of the spring inside the launcher has the same value for different compression distances, referring to the table. Provide enough details so that another student could replicate the experiment, including any steps necessary to reduce experimental uncertainty. As needed, use the symbols defined in the table and or include a simple diagram of the setup. Okay, so what must be done in here? Okay, step number 1. We need to measure the mass of the sphere. Measure the mass of the sphere using triple beam balance. Next, step number 2. We need to aim the launcher towards the motion sensor towards the motion sensor horizontally so that it does not gain any potential energy. We need the object to moving horizontally. To the motion in the launcher towards the motion sensor horizontally on a level surface. Excellent. Part 3. Now we need to compress the spring now, and we need to measure the compression distance. So compress the spring to pin position A. Compress the spring to pin position A. And measure the compression distance. Now we're going to launch as a step number 4. We're going to launch the mass and record the speed measured by the sensor. Launch the mass and record the speed. Measured by the sensor. So part number 5 now. We must repeat steps number 3 and 4 at least 2 more times. We need to repeat so as to reduce the random error. Repeat the launching from point A 2 more times. So we're going to write this down. Repeat steps 3 and 4 2 more times. 2 reduced. 2 more times to reduce random errors. And finally, all these steps 3, 4, and 5 should be repeated from the other positions, from pin positions B and C. So finally, we must repeat steps 3 to 5 from pin positions B and C. Pin positions B and C. That's it. Okay, thanks for watching. Please watch our next video for the remaining part of the problem, as well as all the other videos for the remaining parts of the exam. Also, don't forget to register on our website, www.victoryonlineacademy.com, for free demo registration. I'll see you on our next video.